Thank you very much, ladies and gentlemen. Here we go. All right, today we are on 1.5, measuring and constructing angles. We are almost done here, I think. I don't know if you've looked at the calendar lately. Oh, not too bad. You actually still have a little over a week before we test. So, in about a week, we've got another test here. It's actually Thursday, so a week from tomorrow. Okay, so today we're talking about angles. We've been talking about segments and distance and midpoint, so we're learning a lot about segments, and now we want to transition here to angles. So we want to be able to name, again, focusing on protocol, I guess I would say. Make sure we do things the same all across the world, which is kind of a neat thing about geometry. Wherever we're from, we all do geometry the same way. It's kind of miraculous. All right, and we want to be able to classify angles as well. An angle is formed by two rays with a common end point. So here we have an example of a ray right here. It starts at B, and then it passes through A, and it continues in one direction. So there's only one arrow, so that's a ray. All right, it has an initial point, and it passes through forever that secondary point. So this common endpoint is called the vertex. You can see here our common endpoint is right here at B, so this is the vertex at point B. And the rays are called the sides of the angle. And so we have here, this is ray BA. So the way that we denote that is we do the initial point is B. That's where it begins from. Where does the ray start from? It starts at B. It passes through A. And the symbol is simply an arrow pointing to the right.
Excuse the interruption. The following students need to make their way to Computer Lab 9 for NWEA makeup. Kimberly, Melanie, and Raphael Almanza, Luke Anderson, Robbie Andrus, Ethan Babbitt, Carl Balch, Eli Bassett, Marley Baxter, Archer Bearden, Sophia Birchmeyer, Clayton Boyer, Nicholas Brooks, Peter Brower, Corbin Burke, Parker.
You probably need to take your stuff.
Denise Cebulski, Draven Chalmers,
Maybe.
Aidan Bernstein,
I won't be long.
Amy and Mason Clark. Again, to Computer Lab 9. Thank you.
They might call you down later. Yeah. All right. So BA with a ray on top of it, and it's an arrow that always points to the right. The B is always the initial starting point. Or I guess I should say starting point. The starting point of that ray always goes first. And then we also have ray BC, again, so you'd use capital B and C, and then this is the ray symbol. And it does not matter. For instance, if I draw a ray, like here I'm going to draw a ray CD. So there's ray CD. And would you say that ray is pointing to the left? Okay. Even though my ray is pointing to the left, its initial point is C, and it passes through D. The ray always goes to the right when you write it out. Does that make sense to you? This is just how we name it, okay? And so it's always pointing to the right. Okay, you will get asked this on Delta Math, and they give you an option to have the ray pointing to the left, pointing to the right, or pointing to the left. What way does the ray go? Always to the right, always, always, when we're using notation, okay? Now the picture might be going left, that's fine, but when we name it, it always points to the right. When we name angles, we use 3 letters, and the middle letter must always represent the vertex. So point B is the vertex, and so we would name this angle, you could say ABC. B is the vertex. The A and the C are the sides. You also see the ray in there. BA and BC are the 2 rays within that angle. Is there another way we could name this angle? CBA. So angle, you can see this is our little angle mark. It looks like a little bird beak. Some teachers put a little arc mark through it like that. CBA would be another way to name the angle, and both of them are acceptable. They're both equal, okay? But the only thing is B has to be in the middle because B is that vertex. That's where the angle opens and closes from, okay? We can use a single letter if there's only one angle located at the vertex. So we could just call this angle B if we wanted to. The problem is that sometimes that can be confusing, all right? And I'll show you an example of that later. When referring to the measure of an angle, we use a little lowercase m. So when you see this little lowercase m, it says the measure of angle ABC equals 60 degrees. And so that little m stands for measure. All right, we have some types of angles you already know. What is this angle called? A right angle. It's a right angle. What is the measure of this angle C? I'm going to put a C on here. 90 degrees. I'm going to write the measure of angle C. The measure of angle C equals 90 degrees. Now, it's also really important, and I want you to get in the habit of this now. We're talking about degrees, so you must have a degree symbol on there so that we all understand we're talking about degrees. At some point this year, this will really matter a lot, whether or not we're in degrees or whether we're in radians, okay, which is a whole other thing, and so it's really important that we keep these 2 things straight. So when we're talking about degrees, we want to make sure we have a little degree symbol in there. So this is a right angle. I don't know why I wrote it high like that. So this is a right angle, okay? What's this angle called? Obtuse, And what's this angle called? Acute, A-C-U-T-E, And how do you, what's the measure of an acute angle? Less than 90 degrees. So I'm going to say this is angle A here. So I'm going to say the measure of angle A is less than 90 degrees. Could I put less than or equal to 90 degrees? No, because 90 degrees is a right angle. So we definitely don't want to equal 90 degrees. And obtuse, I'm going to call this angle B. More than 90? Okay, I'm going to restrict that a little bit more. I'm going to say the measure of angle B has to be greater than 90 degrees and less than 180. Yeah, 180 degrees. So we have our right angle, and then anything beyond 90, but only to 180 is what we call obtuse, just like that. And also, acute is really from 0 to 90. Greater than 0 and less than 90 would be an acute angle. What is this called? It is 180 degrees. Yep, this is from here all the way opened up. All right, all the way opened up. That is 180 degrees. So I'm going to call this D. The measure of angle D equals 180 degrees. And it forms a lovely straight angle. So this is called a straight angle. You didn't know that when you draw a line, it's 180 degrees, did you? which kind of makes sense because if we were to put in a 90-degree angle, on one side you have 90 degrees, and what's the other side? Also 90 degrees. And of course 90 plus 90 is 180. Okay, so anytime you see a lovely little straight angle, you know that it is equal to 180 degrees, which is really kind of nice. Okay, all right, so in example 1 here, using this picture, name the vertex of the angle. K is the vertex, capital letter, please. Name the sides of the angle. So there are 2 sides. So what would we call that one? All right, and what's the symbol on top? Arrow, So starts at K, passes through L, and we have a ray on top. That is ray KL. And what's the other ray? KJ. Starts at K, passes through J, arrow to the right, always, always. Okay. Give 3 ways to name this angle. What's one way we could name this angle? Ooh, how many letters do we need to name an angle? 3 letters.
3 ways.
There are 3 ways. There's a
Oh, that's the side.
LKJ is one way. Angle, what's another way? JKL is the other. And because it's a standalone angle, we can also call it angle K. All right. Normally 3 letters is best. Since this is the only angle in the picture, that's totally fine to use angle K. Classify this angle. Obtuse. Good. All right, example 2, name the vertex of the angle. S. Name the sides of the angle. So I'm going to say ray, ST, and ray, SR. Very good. Ray, SR. Beginning at S, passing through R. Give 3 ways to name the angle.
S-C-R.
No.
Why no? S-R-T.
No. R-S-T. The vertex must be in the middle. R-S-T. Or angle T-S-R. The vertex must be in the middle. Okay? T-S-R. And what's the third way? S. Angle S. Classify this angle. Right. Very good. It is a right angle. Congruent angles. If the measure of angle A is equal to the measure of angle B. If their measures are equal, so we can see here, we have angle A and angle B, and both of them have a little measurement of 75 degrees written inside. Okay, the interior, that's the interior space of the angle. Those measures are equal, then those angles are called congruent. So we can say the angle A is congruent to angle B. It's important, this is called the definition of congruence. If the measures are equal, then the angles can be called congruent, okay? So this little symbol means congruent, and measurements are equal, but the figure itself can be congruent. The shapes can be then congruent, and vice versa. All right, let's turn the page. So angle bisector, a ray that divides an angle into 2 congruent angles is called an angle bisector. So in this diagram to the right, ray BD, I'm going to highlight that ray. So BD is right here. There's ray BD. Ray BD is an angle bisector. And what it's doing is it's taking the whole angle, angle ABC, and it is bisecting it. What does bisecting it mean?
Like
going right through the middle, bisect, yep, 2 sections. Bi means 2, and equal sections All right, 2 equal sections. So does it look like BD is cutting the big angle into 2 equal pieces? Yeah. So this, we would usually mark them, and it's hard to tell that it's 2 individual marks there, but we use these congruence markings. So these little arc marks, you might say, to show that this angle here, this little angle ABD, is congruent to DBC. So therefore, angle ABD is congruent to angle DBC. So the 2 little angles are congruent because we have a bisector, angle bisector. So a bisector creates 2 congruent things, and that's something we want to pay attention to. We also have perpendicular lines, 2 lines that intersect at a right angle are called perpendicular lines. And so the symbol for perpendicular is this sort of upside down T. This is perpendicular. It's used in all over the place, but they use it in architecture, of course, all the time too. So this is the symbol for perpendicular. In the diagram to the right, we have a right angle. So right there is a right angle. That's that marking. That's the symbol to tell us. If it's a right angle, what's its measure? 90 degrees. A right angle is 90 degrees. And it also means if we have a right angle, then we have 2 perpendicular lines. So in the picture to the right, line L is perpendicular to line M. If this angle is 90 degrees, what's this angle down here?
90 degrees.
Also must be 90 degrees, okay. And then what's this angle over here?
90 degrees.
Also 90 degrees. And what's this angle right here?
90.
Also 90 degrees. When you have one right angle, that means that there must be all 4 are right angles, okay, if they intersect through, okay? And that's important to realize. How many degrees? 360 all the way around, yeah? Okay, very good. A line segment or ray perpendicular to a segment at its midpoint is called a segment, a perpendicular rather, bisector. And so in the diagram to the right, we see a lot of information. First of all, I see a right angle marking right there with that little box, so I get a right angle, which means if there's a right angle, it must be perpendicular. And I also see the markings here. This is a little congruence mark and another congruence mark. We have 2 congruent segments, which means this intersection must be the middle, okay? It must be the middle of the segment. And so we have a midpoint there. And so in the diagram to the right, we could say that LM, segment LM, or we could say line LM. Line LM, I'm saying line LM because it has arrows, it goes on forever. Line LM is the perpendicular bisector, so it's perpendicular and it's bisecting what? PQ, yeah, segment PQ, and I'm just using segment PQ because this is a segment that does not go on forever. All right, so line LM is the perpendicular bisector of segment PQ. All right, let's look at example 3. What's our time here? I'm just curious how long this is taking. Oh, only 19 minutes. Perfect. 20 minutes is always my goal, so that's great. And I was interrupted. Okay. We have a complicated picture here. How many angles? This is a trick question, by the way. How many angles do you see?
5. 5. 2, 3, 4, 5.
This is a trick question. Yes, you're right. There's a 1, 2, 3, 4, and on the other side 5 angles. But if it B, D, there's another angle. This bigger angle, see that? And then this is a straight angle, so 6, 7. And then here's that one we already counted. But then there's also A, B, F. Did we count that one already? Mm-hmm. And then there's also like, CBD. Mm-hmm. There's lots of angles, D, B, E. Lots of angles in there, aren't there? Okay, so it's really important that we pay close attention to how we name them. And that's why we need 3 letters when we name angles. Write another name for angle CBF. So first of all, I like to highlight, especially in the beginning. If you have another color or a highlighter, it can be really helpful making sure you understand what we're looking at. Angle CBF starts at C, hits B, and then hits F. So there is the angle right here. All right, so there is that little angle with sides BC and BF. So what's another name for that angle? FBC. Angle FBC is a great way. Could I call it just angle B? No, we cannot. Why can we not just use angle B? Because there's multiple angles with B as the vertex. We have a billion. We just counted, like there's at least 10. Okay, so we have to be very careful. Name the sides of angle EBD. So again, I'm going to figure out where that is. Starts at E, hits B, and then passes through D. So here's this angle in pink, right there, pretty big angle there, obtuse angle. What are the sides? Ray, B, D, and ray, B, E. The sides are rays. So BD goes on in one direction and BE goes on in one direction. Classify angle ABC. Oh boy, I need another color here. ABC. Oh, ABC. What's ABC? Straight angle, yeah. It is a straight angle because it is perfectly straight, makes a straight line, straight angle. Give an example of an obtuse angle. So it's an angle, so we need 3 letters, so say it again, Quentin. So B has to be in the middle. So DBC? EBC. Oh, okay. EBC. Yes, EBC from here to here. EBC would be an obtuse angle. All right. EBC. Obtuse. Absolutely. What about EBD? Is that also obtuse? Yeah. All right. Name 2 congruent angles. What are 2 congruent angles? EBA, very good. Angle EBA. That has a marking on there, you can see, and it's congruent to CBF. Angle CBF. Very good. So these 2 angles have a very similar arc mark, and that's how we use those arc marks. You'll notice over here I did a double arc. That's to say that it's different from these 2 congruent ones that have the same matching mark, okay? Name a perpendicular bisector. Perpendicular bisector. BD, yeah. So ray BD, or we could say ray. We could also say segment BD. BD is bisecting segment AC. How do I know that it's bisecting segment AC? Because what does this little mark mean? Congruent. And so we have a congruent mark there and there. So AB, segment AB is congruent to segment BC because of those little markings. So those are two congruent segments, and BD has a perpendicular marking. So because I see that little perpendicular mark and the two bisected segments, then BD is a segment, perpendicular bisector. Okay. All right, last thing. Name the vertex of angle 2. So a vertex, T. A vertex is a single letter. You'll notice we have angles marked with numbers. We do that on occasion. So we have angle 1, angle 2, angle 3, angle 4, angle 5. That's just an easy, quick way to be able to recognize angles. So we can also number them, and they're marked on their interiors. Name the sides of angle 4. So here's angle 4, TZ, ray, TZ, and ray, TW. Again, making sure you're using capitals and proper notation. Write another name for angle 3. Here's angle 3. What's another name for angle 3?
Disruption were Robbie Davis, Paul DePinto, and Emma Donaldson make their way to computer lab number 9. Thank you.
What's another name for angle 3? ZTU would work. Angle ZTU would work. Z, T in the middle, and U. What's another way to name that? UTZ. Beautiful. Okay. Write another name for angle number 1. Angle number 1 is up here. What's another name for angle 1? YTX. Angle YTX. Beautiful. Classify angle YTW. Let's look carefully. YTW is highlighted in yellow. What kind of angle is that? A right angle. Very good. How do we know it's a right angle? We got that little box in the corner. Got the little box. Classify angle YTU. Obtuse. Very good. All right. Classify angle XTU. Yeah, XTU. Again, if I put that, highlight those sides in pink, that can be very, very helpful. It is an acute angle because it's a little skinny, cute one. All right, and WTX, straight, yeah. WTX is a straight line, STRAIGHT. Forms a straight angle. How many degrees are in a straight angle? 180. Okay, a straight angle. Name two perpendicular lines. Okay, yeah, line YZ. YZ, I heard YT is another name for that. So line YZ or YT is perpendicular to WX or WT. WX or WT would work as well. So, very good. Angle bisector. Name an angle bisector. Ray TU is an angle bisector. How do we know that it's an angle bisector? It's in the middle of the angle. How do we know it's in the middle of the angle? What markings indicate that? Yeah, these little arc marks. So those little arc marks are congruent. They're saying angle 2 is congruent to angle 3. They're the same measurement. So that means that TU is going right through the middle of XTZ. Super. Do you have questions for me? All right, isn't that fun? Just all sorts of naming and vocabulary and everything. All right, you guys have a little Delta Math to work on today. Read carefully. I will open that up for you now. Oh, let me stop it. Great.